Welcome back to Max with RP. Today we are going to solve word problems using the concept of maxima and minima. Now look at this problem. We want to find the maximum slope of this curve. Okay? That is, you know what is the slope of this curve? Slope of the curve is given by slope of the curve is dy by dx. dy by dx is equal to minus 6x square plus 12x plus 4. Slope of the curve is nothing but slope of the tangent. What do we mean by the slope of the tangent to the curve? What is that? That is represented as dy by dx, which is minus 6x square plus 12x plus 4. Okay. Now I am going to call this as some function f of x equal to minus 6x square plus 12x plus 4. I want to maximize this. Okay. So let us find df by dx. Then what will I get? Minus 12x plus 12, okay, which is equal to 0, implies minus 12x equal to minus 12 or x is equal to 1. So the critical point is, this is the critical point. Okay, now in order to prove this is maximum, we want to now find out whether at x equal to 1 you have maximum or minimum. We have been doing the first derivative test, but second derivative can also be used to find whether a function has maximum or minimum. This is the given function. This is the first derivative. Now I am going to find the second derivative. This is the function. Okay. Now what will be the second derivative? D square f by dx square. That will give me, that means you have to differentiate this, which is give me minus 12, which is less than 0. If second derivative is less than 0, the function has a local maximum at x equal to 1. That is the second derivative test. X equal to 1 is the critical point. That is a point where, it could be a point of local minimum or maximum. So how to find out whether it's a point of local minimum and maximum? Instead of using first derivative, I am using second derivative. I am differentiating it once again. I get minus 12, which is less than 0. If the second derivative is less than 0, then the function has a local maximum at x equal to 1. So what is the local maximum value? So what is the maximum? So what is f of 1? F of 1 will be minus 6 plus 12 plus 4, which is 10. So the maximum slope for this curve y equal to minus 2x cube plus 6x square plus 4x minus 11 is 10. I have maximized the slope. The slope of the curve, what do you mean by that? Slope of the tangent to the curve, which is dy by dx. So that itself I have taken as a function. I am calling it as f of x. Then I have done the first derivative, I have done the second derivative. Using first derivative by equating it to 0, I found the critical point. So x equal to 1 is the critical point. Now the second derivative is minus 12, which is less than 0. If the second derivative is negative for x equal to 1, then x equal to 1 is a point of local maximum. And what is the maximum value? I have substituted in f of x. I have found f of 1. I have got f of 1 equal to 10. So the maximum slope is 10. Now, we have to prove that of all the rectangles that can be inscribed in a given circle, the square has maximum perimeter. So, if I take a circle, I can inscribe infinitely many rectangles. How many rectangles can I inscribe? When I say inscribe, its vertices lie on the circle. So, like this, I can inscribe infinitely many rectangles. But we want to prove that of all these rectangles, the one which has got maximum perimeter is a square. So, we are going to prove that of all these rectangles, the one which has got maximum perimeter has to be a square. Okay. So, let us take again, let me draw the circle. I am going to inscribe a rectangle. The circle is fixed. Circle is given. So its radius is a constant. Okay. Let me take a rectangle. Okay. Let the dimensions of the rectangle be x and y. Now, this will be the diameter. Okay. So, for convenience, I am going to take, or rather because I have taken r to be the radius, it has to be 2r. Okay. Now, we have to maximize to find maximum perimeter. Now perimeter is the perimeter of the rectangle is 2x plus 2y. Both x and y are variables because I can have infinitely many rectangles. X and y are variables. Okay. Now the perimeter is 2x plus 2y. I cannot differentiate p because it's a function of two variables. So I need to express it as a function of a single variable. So what is the relationship that connects x and y? We know that by Pythagoras theorem, x square plus y square equal to 4r square, or y square equal to 4r square minus x square. Or y is root of 4r square minus x square. Now what will be the perimeter? Perimeter is 2x plus 2y, that is 2 into root of 4r square minus x square. I have to differentiate to find the critical point. So dp, it has now been expressed as a function of a single variable x, or is a constant. So I am going to find dp by dx. Therefore, will be derivative of 2x is 2 plus derivative 2 into derivative of this will be 1 by root 2 root of 4r square minus x square. Okay, into derivative of minus x square, which is minus 2x. Now dp by dx equal to 0 implies 2 equal to 2x by root of 4r square minus x square. Squaring 4 equal to 4x square by 4r square minus x square. So what will I get? 16r square minus 4x square equal to 4x square, or 16r square equal to 8x square. Therefore, x is equal to 2r. 16r square is equal to 8x square. So x square will be 2r square. So x square equal to 2r square. So x is root 2r. If x square is 2r square, what is y square? We know y is root of 4r square minus x square. So substituting in 1, you get y equal to root of 4r square minus 2r square, which is again root of 2r square, which is means y is root 2r. So x is equal to y. So if x is equal to y, then what can you say? It is a square. Therefore, it is has to be a square. So I have assumed that dp by dx is 0. So I found a critical point. Critical point is at x equal to root 2r. So if x is root 2r, then y is also root 2r. So that we have seen. But we also have to check whether that x at x equal to root 2r, whether we have a point of, since it says maximum perimeter, whether x equal to root 2r is a point of local maximum. That means we have to check the second derivative. Okay. So till this, I hope you have understood. We will now do the checking with the second derivative. I am removing this. Okay, so what is dp by dx? Now dp by dx is equal to 2 minus 2x by root of 4r square minus x square. 2 minus 2x by root of 4r square minus x square. Now please remember, if d square b by dx square is negative, then it's a point of local maximum. So derivative of this is 0. Okay. So I get minus 2x by root of 4r square minus x square. Okay. And what is the value of x? X is root 2r. So if I put x equal to root 2r, what will I get? Minus 2 root 2r by root of 4r square minus x square is what? 2r square. This is minus 2 root 2r by root of 4r square minus 2r square is what? Root of 2r square, which is minus 2 root 2r by root 2r. So it is minus 2, which is less than 0. So x equal to root 2r is a point of local maximum. So when x is root 2r, the perimeter is maximum. But we observe that when x is root 2r, y is also root 2r. So when the perimeter is maximum, it can only happen when x is equal to y, when it is a square. I hope you have understood all the calculations and how to use the second derivative in checking whether a particular point is a point of local maxima or minima. Look at the next problem. Show that of all the rectangles inscribed in a given fixed circle, the square has maximum area. So you have a circle and you have how many rectangles you can inscribe inside the circle? Infinitely many rectangles. Infinite rectangles can be inscribed in a fixed circle. So if a circle is fixed, what does it mean? The radius is constant. Okay. Now let me draw a rectangle. Let the dimensions of the rectangle be x and y. Let r be the radius of the circle. So diameter is 2r. Okay. So r is a constant. Why? Because the circle is fixed. X and y are variables because you can draw infinitely many rectangles. We are only going to prove the one which has got the maximum area is the one which is a square. Okay, so we are going to maximize the area of the square. Now area function is equal to x into y. So I have to now substitute. Again, it's a function of two variables. So I have to express it as a function of a single variable. So what is the relationship between x and y? X square plus y square equal to 4r square. So y square equal to 4r square minus x square. So a square equal to x square y square, which is equal to x square into 4r square minus x square. See, if a is maximum, then a square also has to be maximum. So I am looking at x square y square by squaring because I need not worry with I need not work with the square root. Okay, but you can also do it by substituting like I did in the previous problem. Y is root of 4r square minus x square. That method can also be used. Now a square is x square into 4r square. I am just showing you different ways of doing a problem. So a square is x square into 4r square minus x square, where x is a variable, r is a constant. So a square, I am going to call it as k equal to 4r square x square minus 4x power 4. This a square, I am going to take it as some k. That will be what? 4r square x square minus 4 minus x power 4. Now dk by dx, because only x is a variable, r is a constant, will be 4r square is a constant into derivative of x square is 2x minus 4x cube. To find the critical point, dk by dx is equal to 0. Therefore, 8x r square equal to 4x cube. 4 goes 2 times. So 1x gets cancelled. 2r square equal to x square. So x is root 2r. What will be y? From this you know y is root of 4r square minus x square. So y is root of 4r square minus x square, which is 2r square, which is also root 2r. So we have got it that it is a square. And what is the critical point? X is root 2r. When x is root 2r, we have seen y is root 2r. But we have to check whether x equal to root 2r is a point of local maximum. That means I have to do d square x by dx square. Okay, so d square k, I use a different color. D square k by dx square will be equal to, so if I differentiate, this is my dk by dx. So if I differentiate this with respect to what? X. What will I get? 8r square minus, if I differentiate this, what will I get? 12x square. This is 8r square minus 12 into, what is x square? X square is 2r square. So from here, x square is 2r square. So this is 8r square minus 24r square minus 16r square, which is less than 0. So x is equal to root 2r is a point of local maximum. So, of all the rectangles that can be inscribed in a fixed circle, when we say fixed circle, the dimension of the circle is a constant. Then the one which has got maximum area has to be a square. Is it clear? Are you able to follow this? Please go through. I have done only 3 problems today because we are just starting with word problems. So just go through these 3 problems and then we will do plenty of word problems based on maxima and minima until you become very confident and thorough with the concepts. The difference between what we have done today and in the earlier one is the earlier examples I've used the first derivative test to find local maxima minima, whereas in the word problems I'm using the second derivative test because it's much easier sometimes to use to check whether a particular point represents a point of local maxima or minima. So please go through what we have covered today and practice these 3 sums. So for the next video we will have another set of problems we will discuss. Until then, it is goodbye.